Welcome to our show, where today we're diving into quantum computing, a topic so confusing, even Schrodinger's cat isn't sure if it understands. Jones, kick us off. What makes a quantum computer different from my trusty laptop, besides the fact that one needs a physics degree to operate?
Thanks for having me. Imagine your laptop as a diligent office worker who files papers one at a time. A quantum computer, on the other hand, is like a magician who can file all the papers simultaneously, thanks to qubits, which can be in multiple states at once due to superposition. It's multitasking on a cosmic level.
Wait, so qubits are like indecisive squirrels, never sure if they want to be a 0 or a 1, but somehow that's a good thing?
Exactly. And with entanglement, qubits can be weirdly linked, like synchronized swimmers who've never met but somehow execute flawless routines. This lets quantum computers tackle problems classical computers would need centuries for.
So, if I had a quantum computer, could I finally win at Minesweeper? Or is it reserved for more noble pursuits?
Well, it might solve Minesweeper so fast it forgets to let you play. But yes, the real promise lies in fields like cryptography, chemistry, and optimization, though. Let's be honest. Beating Minesweeper would be pretty legendary.
Now that we've established qubits are basically the drama queens of the computing world, let's dig deeper. How are these finicky little things actually created and controlled?
Qubits can be crafted from trapped ions, photons, or superconducting circuits cooled to temperatures colder than your freezer's freezer. Controlling them is an art. If you so much as sneeze near a qubit, it might change its state. That's why quantum labs look more like NASA than a typical IT department.
So, quantum engineers are basically cat whisperers, but for particles? I assume this fragility is why we don't all have quantum smartphones yet.
Spot on. Decoherence when qubits lose their quantum mojo due to interference is a huge hurdle. Some qubits can only hold information for microseconds. It's like trying to write a novel before your pen evaporates.
Given all this, how do researchers keep qubits stable long enough to do anything useful?
They use fancy error correction codes and shield qubits from anything remotely fun: heat, light, even cosmic rays. It's like raising a toddler in a bubble, hoping it grows up to solve the world's hardest math problems.
Let's stage the ultimate showdown. Quantum computers versus classical computers. In what scenarios does quantum really outshine our everyday silicon machines, and where does it fall flat on its quantum face?
Quantum computers excel at tasks like factoring huge numbers, simulating molecules, or optimizing complex systems, things that make classical computers weep binary tears. For example, breaking modern encryption could take a classical computer billions of years, but a quantum computer might pull it off in minutes once it gets out of beta. That is.
That's both impressive and terrifying. But surely quantum computers have their Achilles heel, right?
Definitely. For everyday tasks like web browsing or streaming cat videos, quantum computers are as useful as a chocolate teapot. They're specialists, not generalists. Plus, scaling them up is like herding cats, quantum ones.
So, in a nutshell, my laptop remains the reigning champion of Netflix binges, but quantum could one day revolutionize areas like medicine or logistics.
Absolutely. Think of quantum computing as the superhero with a very specific set of powers. It won't do your taxes, but it might just cure cancer or save the planet while looking fabulous in a lab coat.
Let's wrap up by gazing into our crystal ball, or quantum superposition sphere. What are the most exciting real-world applications on the horizon? And what's holding us back from a quantum-powered utopia?
Quantum computers could revolutionize drug discovery, optimize supply chains, and supercharge AI. For instance, a 2022 MIT study showed quantum algorithms reduced protein folding simulations from months to hours. But the hardware's not quite ready to join the Avengers just yet.
If the hardware is lagging, are there any promising breakthroughs on the near horizon? Or are we still in the era of quantum vaporware?
Great question. Companies like IBM and Google are racing to build bigger, more reliable quantum machines. And there are tantalizing hints like Google's 2019 announcement of quantum supremacy. But for now, most applications are still in the research lab, not the App Store.
So, should our listeners invest in quantum stocks, or just invest in popcorn for the next big quantum announcement?
I'd say popcorn is the safest bet for now, but keep your eye on the field. Quantum computing may just pull off the greatest plot twist in tech history. And you heard it here first, in a superposition of being both early and late to the party.